You know, when we think about fighting cancer, we usually picture this war against individual rogue cells. But what if that's not the whole story? What if we're missing the bigger picture? Today, we're going to dive into a really revolutionary way to understand and maybe even defeat cancer's deadliest move, its ability to spread.
First things first, let's just get a reality check. Get this. The source material we're looking at today points out that around 80% of all cancer deaths aren't actually caused by the first tumor. Nope, they're caused by what happens next. Metastatic cancer. That's the real mountain we have to climb.
So, that leads to a really important question. If just going after the primary tumor isn't solving the deadliest part of the problem, what if our whole strategy needs a reboot? What if we've been fighting the wrong battle all along? Okay, to really wrap our heads around this new approach, we first have to appreciate cancer's most dangerous play. Let's break down its deadliest trick, how it actually spreads.
See, a single tumor, one that's just sitting there in one place, that's often something we can handle. We've got surgery, we've got radiation, we have tools for that. The real life-threatening danger comes from metastasis. That's the process where cancer cells break away, travel through the body, and start setting up new shops, new colonies in totally different organs. That spread is what we have to stop.
So how do we stop it? Well, the answer might actually start with understanding the rules of a healthy body in the first place. And this brings us to a new framework for thinking about biology, and it gives us this powerful new lens to see what's really going on.
In a healthy body, you've got this beautiful three-level system of control. Down at the bottom, at the micro level, we'll call it T, you have individual cells just doing their jobs. In the middle, at the meso level, or C, you've got cells working together in their local neighborhoods. But, and this is the big one, at the very top you have the macro level. It's represented by the Greek letter lambda, or Lao. Think of this as the boss. It's the whole organism, the immune system, the circulatory system, all the big picture rules that tell every other part how to behave.
And this quote just nails it. The health of the entire system, that macro-level lambda, is what sets the rules for all the individual parts. It's a top-down system, and its job is to make sure everything works together for the good of the whole team.
Right, so if a healthy body is all about these top-down rules, then what is cancer? Well, cancer is what happens when a system learns how to break those rules and starts playing its own game, creating what we can call a rogue loop.
And this is the absolute key difference. In a healthy body, everything is aligned. The organism, the lambda, is in control. But cancer creates what the source material calls a splinter system. It basically says, I'm not listening to you anymore. It breaks free from the body's authority and starts building its own environment, its own supportive macro system, a totally rogue lambda.
And the result of that is, well, it's pretty profound. The tumor isn't just a bunch of bad cells anymore. It becomes this parasitic organ living inside the body. It starts acting like its own organism with its own goals, its own need for resources, and its own powerful drive to survive. Now, thinking about cancer this way, as a competing system, it's not just some interesting idea. It actually reveals a massive critical weak point, a vulnerability that we can totally exploit. Think about it. That first primary tumor, it's strong. And why is it strong? Because it has successfully built its rogue base of operations. It's recruited its own blood supply. It's figured out how to hide from the immune system. It has created a stable, supportive little world for itself, its own personal lambda. It's running its own show.
But then, what happens next? A single cell, maybe a little clump of them, breaks off. It leaves the safety and stability of that cozy, custom-built home it worked so hard to create.
And now it's got a huge problem on its hands. It's a lonely pioneer landing in a completely hostile new territory, a different organ that's still playing by the body's original healthy lambda rules. Can it really build an entirely new base, a whole new support system, from scratch, all by itself?
And that right there, is the whole game. This is what the framework calls the lambda bottleneck. A traveling cancer cell is basically harmless unless it can successfully build or hijack a new supportive home for itself. The need to construct a new lambda is the single biggest hurdle it has to overcome, and that makes it Metastasis's absolute weakest link. So suddenly, the new strategy just clicks into place. Don't just attack the cancer cells, attack their ability to build a home.
And what's so cool about this is, in a way, we're already doing this. Some of our best modern therapies are already lambda-level attacks. For instance, checkpoint inhibitors don't kill cancer directly. They take the brakes off our own immune system, letting it see and destroy the cancer's entire supportive neighborhood. And drugs like anti-VEGFs, they're not killing cells. They're cutting off the tumor's ability to build new blood vessels, basically starving its rogue system.
This whole perspective just blows the doors open on a brand new map of future battlegrounds. Instead of only looking for new cell-killing poisons, we can now look for ways to target the entire rogue system. This includes incredible stuff like finding the dormancy switches to tell sleeping cancer cells to just stay asleep forever, or even disrupting their exosome logistics. These are like tiny little packages that tumors send out ahead of time to prepare new organs for an invasion. It's wild.
And we can actually lay this all out on a roadmap. In the near term, the idea is to use tools we already have, or ones that are close, to stop cancer cells from ever setting up a new colony and to prevent relapse. Then, in the midterm, we can develop new tech to block their construction crews and their long-range communications. And the long-term vision? It's about re-architecting our body's own systems, like our microbiome or even our circadian rhythms, to make our bodies permanently hostile territory for cancer.
So when you boil it all down, it comes to this. The whole paradigm shifts. The goal isn't just a brute force mission to kill every single last cancer cell anymore. It's a much smarter, more strategic goal. Collapse the rogue system itself and make it impossible for those cells to survive in the first place.
And that leaves you with a final kind of mind-bending thought, right? What if the future of medicine for our toughest diseases is less about finding that one magic bullet and a lot more about becoming master architects and even gardeners of our own biological landscapes?